Hello, you're welcome to the Chemistry Mastery Academy. My name is Christopher Pogome. Today we're going to be looking at the topic bases and alkalis. Bases and alkalis. Now, what did we say bases are? But before we proceed, let me correct something, a mistake we made in the last class. Now, we actually asked a question that if acid is added to water or whether water is added to acid. Now, the correct thing is that acid is added to water. So, the rule is this: always add acid to water. But when you are adding acid to water, don't just pour it immediately. No, rather, what you should do is what? Place the bottle containing the acid by the side of the container or bottle containing the water and pour it such that it flows through the side of the container that is containing the water into the water. Okay, so always add acid to water. Do not add water to acid. Exactly. All right, so having said that, let's move to our class for today. We're looking at bases and alkalis. Now, what is a base? We have here that a base is a substance which will neutralize an acid to give us what? A salt and water only. A base is a substance that will neutralize an acid to give us salt and water only. Now, I want you to take note of something. Now, the base does what to an acid? It neutralizes the acid. That is, it takes away the properties that makes the acid an acid. Okay, that's what we mean by what? Neutralize. It takes away the properties that makes the acid an acid. One. Two, after taking away the properties that makes the acid an acid, it produces two products only two products. And what are those products? Salt and water. Exactly. So it means that one of the conditions that must be fulfilled in order for you to categorize a substance as a base is that when that substance reacts with a base, it produces only two products, which are salt and water. Exactly. Now, another definition for a base is that a base is a substance that is made up of a metal and an oxide or hydroxide. A metal and an oxide or what? Hydroxide. Exactly. That's another definition for a base. Now, we have here most oxide and hydroxide of metals are bases. So, when we say a base is a substance that is made up of a metal and an oxide or a metal and an hydroxide, it is not in all scenarios because there are some substances that are made of metals and oxide or metals and hydroxide. When they react with an acid, they will not produce salt and water only. They will produce salt, they will produce water and other substances in the process. So such kind of what? Metallic oxide or such kind of metallic hydroxide cannot be categorized as a what? A base. Are we following? So it means that it is not all oxides and hydroxides of metals that are categorized as what? As base. Exactly. Alright, so now let's look at alkali. An alkali is a basic hydroxide which is soluble in water. What do you mean by that? A base, when you mix it with water and it dissolves or it mixes with the water and forms an homogeneous substance, that base automatically have become an alkali. So an alkali is a substance that is a base with the ability to dissolve in what? In water. An alkali is a substance that is a base with the ability to dissolve in water. That's why we have here that an alkali is a basic hydroxide which is soluble in water. Are we following? Now we have some alkalis: sodium hydroxide, potassium hydroxide, calcium hydroxide. So now we also have, remember we said basic hydroxide, right? We also have basic oxide too that are soluble in water that can be categorized as what? Alkalis. So the point here is this: for a base to become an alkali, it must be soluble in water. So for you to call a substance an alkali, one, it must be a base. Two, that base must be soluble in water. So having said that, remember we said something at the beginning that it is not all metals of all metallic oxide or metallic hydroxide that are categorized as base. The only reason why they will be categorized as base is if when they react with acid, they produce water and salt only. But there are some metals of oxide or metallic hydroxide that when they react with an acid, they don't produce salt and water only. They produce other substances as well. For example, we have lead 4 oxide. Now, when lead 4 oxide reacts with an acid, as you can see here, we have salt, we have water, and we have what? Chlorine gas. So this lead 4 oxide is not a base. Why? Because it does not produce salt and water only. It produces salt, it produces water, and it also produces another substance called chlorine gas. That's why lead 4 oxide is not a base. Is that clear? So having said that, let's move further. So we have from the equation above, lead 4 oxide is not a base. The nature of the hydroxide of the metals varies according to what? The position of the metal in the electrochemical what? Series, as illustrated below. So we have explained that. Now let's look at some metals, their solubility, and the composition by heat. Now, here we have potassium, sodium, and calcium. Now, potassium, sodium, and calcium are base, or rather they can form base. That is, they can react with hydroxide to form a base. So the hydroxides of these metals, potassium, sodium, and calcium, are soluble in water. So it means that if the hydroxide of potassium, sodium, and calcium are soluble in water, that means potassium hydroxide, sodium hydroxide, and calcium hydroxide are alkalis. Remember what we said concerning alkalis. Alkalis are substances or bases that are soluble in what? In water. Is that clear? All right. Now, magnesium, aluminium, zinc, iron, lead, and copper, the hydroxides are not soluble in water. So they are not what? Bases. Is that clear? So these metals form hydroxide which are insoluble in water. So while potassium hydroxide, sodium hydroxide, calcium hydroxide are soluble in water and so they are alkalis, magnesium hydroxide, aluminum hydroxide, zinc hydroxide, iron hydroxide, lead hydroxide, and copper hydroxide are not soluble in water, so they are not what? Alkalis. Now we have mercury, silver, and gold. These ones, they don't have hydroxide. Is that clear? They don't have hydroxide. So they don't have hydroxide, they cannot be base, they cannot be what? Alkali. Is that clear? Alright, so let's move further. Now, just as we talked about strength of an acid, we also have strength of what? Of base. We also have strength of what? Of base. Now, a weak base is one that what? Ionizes slightly in aqueous solution. A weak base is one that ionizes slightly in aqueous solution. Now, we've already established what we mean by ionizes. That is, a weak base does not release all of its what? Hydroxide. It does not release all of its what? Hydroxide. Let's see something. Now, let's look at sodium hydroxide plus HCl. Now, sodium hydroxide plus HCl will give us what? Sodium chloride plus what? H2O. Now, this is the base. Okay? Sodium is a metal and we have hydroxide. Okay? So, sodium hydroxide, right? Now, this is the hydroxide. This one that is in the box. This is the hydroxide. When it reacts with the acid, which is hydrochloric acid, what happens? It releases all of its what? OH. As you can see at the product side, we have Na. Okay, being joined to what? Chlorine. So the OH left and went to attach itself to this H to form what? Water. So this sodium hydroxide is a what? A strong base because it releases all of its what? Hydroxide. It releases what? All of its what? Hydroxide. So it's a strong base. Now, in a situation whereby it does not release all of its hydroxide, it automatically becomes a what? A weak base. Let's look at this example. NH3 plus H2O. That's hydride of nitrogen plus H2O. Now, when this combine, we'll have NH3, OH, right? I hope I'm not mistaken. Let's see. NH3, H2O. Okay, so we have NH3 plus, there's an extra NH4, then OH. Are you seeing it now? N is 1 here. H3 plus 1 of this hydrogen make it 4. So we have H4. Then the remaining hydrogen that is here comes here, than this what? Oxygen. Are you seeing what's happening here now? It does not lose all of its what? Hydroxide. Are you seeing it now? So hence this is a weak base. This is a weak base. Okay, so having said that, now what are the properties of alkalis? Now, of course, we know that in chemistry, when we're looking at properties, we look at the physical properties, we look at the chemical properties. Physical properties are those ones that you can actually see, while the chemical properties are those ones that are internal, responsible for the behavior of the words, particles that make up what? The substance. Now, physical properties of alkalis. One, alkalis have a bitter taste. They have a bitter taste. They have a bitter taste. Have you tasted what do you call it? Have you tried to taste soda before or soap? How does it feel? So that's the bitter taste we're talking about. So now we have alkalis are soapy to the touch. So when you touch them, they're like soap. You know how soap feels in the hand and when you touch it. So alkalis are soapy to the touch. They are soapy when you touch them. Alkalis turn red litmus to blue. Remember, we said that when you want to check whether a substance is an acid or any other substance, what do? You take a blue litmus paper and you put it inside the substance. If that blue litmus paper changes to red, it means that that substance is an acid. Now, for a base or for an alkali, you take a red litmus paper, you put it inside. If it is a base, the red litmus paper will change to what? The color will change to what? Blue. Then another physical property of alkali is that concentrated form of the caustic alkalis of sodium hydroxide and potassium hydroxide are corrosive. You know when they're corrosive? We have explained that in our last class. When we say corrosive, that is, it can what? Cause burn on your skin. It can cause your skin to begin to peel. We said concentrated form of the caustic alkali. Caustic alkali. Now, you have observed that there are sometimes when you are washing your clothes, after you have washed for a long time, you discover that your hand will start peeling, right? It's as a result of the presence of concentrated form of what? Alkalis, of sodium hydroxide and what? Potassium hydroxide, that is present in that what? Soap. Remember, we said alkalis are soaps or can be found in our soap. Remember, we said they are soapy to what? To the touch. It's not so good. So when you have concentrated form of sodium hydroxide and potassium hydroxide in that soap, by the time you use the soap for some time, you discover that your hand will start what? Peeling. Hence, we say is what? Corrosive. Alright, now let's look at the chemical properties. Now, chemical properties of alkalis. One, alkalis react with acid. We have established that already. So when they react with acid, they form what? Salt and water only. Then next is that they displace volatile ammonia from ammonium salts. They displace volatile ammonia from ammonium salts. What are we saying? All we simply mean is this. Let's write that on the board. Let's see. They displace volatile ammonia from ammonium salts. Let's look at this now. So we have sodium hydroxide. We know this is an alkali, right? Then they displace base or alkali displace what? Volatile ammonia. That is, they remove ammonia from where? Ammonium salt. Ammonium salt chloride. Okay, so now this is an alkali reacting with ammonium salt. Okay, ammonium chloride. When they react, let me bring it down here like this. When they react, right, what will they form? The ammonia that is in this salt, this base will remove it. So what will we now have? We will now have NH3. This is ammonia plus what? We have Na, we have Cl, and then what else do we have? NaCl, that's what we have here. Then we have NH3. So how many hydrogen is remaining? We have one hydrogen remaining. Okay? We have like one hydrogen what? Remaining. But now the point here I'm trying to show you now is this base has succeeded in what? Removing ammonia from this substance. Look at the ammonia out here. Is that clear? Alright. Okay, so let's proceed. Now, what are the uses of what? Alkalis. Now, sodium hydroxide is used to make what? Soap. Is used to make sodium salt and is used to make what? Plastic. Sodium hydroxide can also be used for the refining of petroleum. So it's part of those materials that is used to what? Refine petroleum to get out those what? Different component that makes up your what? Crude oil. Then potassium hydroxide is used in the manufacture of liquid soap. Do you remember what we said before? We said that the concentrated form of sodium hydroxide and potassium hydroxide, they are what? Corrosive. And now here we are saying that sodium hydroxide is used to make soap, potassium hydroxide is used to what? Make soap. So that tells you that in your soap that you use in your houses, you have sodium hydroxide in it, you have what? Potassium hydroxide in it. Now when these substances become highly concentrated in that soap, it will now lead to what? Corrosion on your skin. That is, it will not cause your skin to what? Peeling off. Exactly. Alright, so we have calcium hydroxide, which is used in what? In the manufacture of mortar, cement, and what? Plaster. Okay? Calcium hydroxide used in the manufacture of what? Mortar, cement, and what? Plaster. And it's also used in dissolving acidic soil. So if your soil is acidic, okay, it has a lot of acid in it, what do? You add what? Calcium hydroxide. What does it do? It goes in there and neutralizes the what? Acid. Remember, an alkali reacts with an acid to form salt and water only. Let's move further. The magnesium hydroxide is used in the manufacture of toothpaste. Toothpaste, what we use to brush our teeth, has what? Magnesium hydroxide in it. Then we have aqueous ammonia. Of course, aqueous ammonia is an alkali. So what is it used for? It is used for bleaching our cloth, is used as detergent, and is used as what? As a laxative. Alright, now we have already talked about neutralization reaction in last class. Basically, what is neutralization reaction? Neutralization reaction is basically the reaction of a base with an acid to form salt and water only. As the term implies, neutralization. So basically what we are doing is that we are removing the acidic properties in the acid such that it is no longer an acid anymore. Okay? All right. So in our next class, we are going to be looking at salts. Salts. All right. Do well to subscribe to our channel so that you can always get notified of our new videos in our Chemistry Mastery Academy. Do have a nice day.